Okay. All right, so don't forget, we do have the on-demand Zoom office hour for the TA. If you got any question related to any earlier labs or the current lab, you can definitely reach out to them. For your lab number 4, I know it was supposed to be released on the past Monday, but since we haven't really started talking about inheritance just yet, which I plan to do today on the second half, so I will postpone, I kind of shift the 2 weeks period for lab number 4 by 1 week. So you will get your lab number 4 next Monday, and you still get 2 weeks to do it. So don't worry, you're not missing any time. And lab number 4 is not going to be covered by the coming programming test number 2. It's only going to impact your programming test number 3, all right? The last programming test. So you're not going to be impacted. Your written test number 1, the result has been released. If you want me to go over questions with you, or if you got any concern, feel free to drop by, and then we shall talk. Programming test 1 result, I'm just waiting for a couple of TA for their part to be done. They were supposed to reach out to me, hopefully by the end of today. I'll reach out to them. If I can release maybe earlier than Monday, I'll do so, but definitely Monday, that's for sure. I know there might be some important decision for you to make on Monday. Hopefully everybody will stay after Monday. But I'll reach out to you about programming test 1. And for your programming test number 2, it's going to be next Friday, July 11th. So tomorrow, the lab session there will still be Q&A. You can drop by and ask the questions. Excuse me. I'm going to give you the guide just to lay out some important information, especially for the coverage for your programming test number 2. I'll definitely do it tomorrow, so you can definitely start preparing. For the practice test, we are still finalizing it. Most likely, it'll be Monday. On the coming Monday. So just do some study, go over the lab, and go over lecture material over the weekend. And then once you receive the practice test on Monday, you can start preparing for that. And then as before, we are also going to hold a review session there on Wednesday, most likely in the afternoon. I'll confirm with you about the exact time and also location. And we'll just go over the solution together with you for the practice test. And your priority now for lab number 3, I already released the solution and also with the previous lab. So please just catch up with whatever study that might be missing from your plan. Okay? Any questions? Yes?
So just to clarify, last quarter released on the 7th of July and then released on the 25th?
Yeah, that's correct. So yeah, so for your lab number 4, you can definitely refer to the calendar. I'll update that very soon. So it's basically shifted by exactly 1 week. You'll still be receiving 2 weeks to do the lab number 4. And I'll also give you detailed solution afterwards, so nothing will be impacted for your learning. So good. All right, let's now do some very quick recap from last time. Okay, so today the plan will be in the first half, I want to do one more example about the equals method, just to finish one more example that could be also helpful for your upcoming programming test. And then in the second half, I would like to start with arguably the most important and exciting topic for this course, which is about inheritance. We're going to spend definitely today and 6 more classes on inheritance. I'm going to go in very depth into the inheritance. The slides are already there, so don't worry, it's very giant slides that we're going to go over, but I'll make sure I'll go over all the details together with you in class. So maybe you haven't really attended class often, start attending classes, right? Inheritance is a very, very important topic for you to learn. It's going to impact definitely 2101, the data structure course, because they assume proficiency on your Java ability. And also 3311, software design. Many design patterns you're going to learn in 3311, they rely on polymorphism, dynamic binding, and also inheritance. So it's a must know, right? I'll make sure you guys properly learn in the lecture. And of course, lab number 4, lab number 5 are going to give you chances to practice. All right, we'll get there. Okay, very, very quick recap about last time. So last time, we basically just continued with the equals method. Specifically, we tried to review about the short circuit evaluation, right? So now we cover both the conjunction and disjunction, right? So just go over the details about maybe the truth table, start with that, and also about the eval. So there are 2 orthogonal aspects you have to know about short circuit evaluation. Number 1, the order of evaluation is always from left to right. Number 2, depending on which operator you're using, if the left-hand side is already true or false, you may not have to evaluate the right-hand side, right? Depending on the situation. So that's kind of the hint you want to give to yourself when you study for short circuit evaluation, right? Just go over the example that we spoke about in the class, and then also try to use them also in the labs as well, okay? And especially this page here, I think that's quite nicely summarized about how you should really interpret the left-hand side condition. If you're using conjunction over here, this will be more like a guarding constraint. And if you're using disjunction here, it's more like an error condition. As to why, you can refer to the recording last Thursday. Okay. Or reach out to me if you got any question. And the typical exceptions or errors we want to guard or prevent will be array index out of bound or null pointer exception. That's typically the ones. But of course, you can be more creative about guarding your expression. All right, so that's about it. And that's a very important application of the short circuit evaluation for our equals method. Basically, we say phase number 2 and phase number 3, they both return false. So why don't we say either this is true or this is true, and we might return false. And we spoke about the order of placing the number 1 and number 2, or number 2 followed by number 1. They do make a difference. Remember the first aspect for short circuit evaluation. Evaluation go from left to right. Either you go from left to right this way, or go from left to right this way. It's going to make a difference, right? Maybe review the discussion we had from last Thursday. There will be another example in the equals method I'm going to talk about today. For that one there, I'm going to point it out to you guys. You can also take a look at that for exercise. Okay. All right, and we definitely are going to go talk about extents today once we get to inheritance, right? That will be definitely the basic keyword you have to know, but I'll leave that a little bit later, okay? So this page here basically summarizes about, you might either call the default version of the equals method, or you call the overridden version of the equals method. And just remember again, so there are two kinds of types that we spoke about so far, static type and also dynamic type. To really determine which version of the equals method that's going to be called, you want to look at dynamic type. All right? That's something we're going to emphasize over and over and over when we talk about inheritance. So here, we only talk about which version of the equals method you will call in this particular context. Once we generalize it, when we talk about inheritance in general, we have to talk about arbitrary methods, depending on which inheritance hierarchy you're defining. Right? We'll get there. But I just want to tell you guys, make sure you understand this page here and see which version you might be called. Right? Look at the recording if necessary. All right, so we talk about logical implication, right? If you got any trouble understanding it, let me know. Otherwise, I assume you're okay. We basically talk about so this will be the final statement you have to understand, not necessarily memorizing, right? You can always try to derive it with some rationale, just in case you forgot. So we are saying that if two objects are reference equal, they are the same address, then for sure, if you call equals method on by one on the other, it's going to be true as well, but not vice versa. So please refer to the detailed discussion. And to really show that the other way is actually not necessarily true always, we do provide with you some counter example to show that, right? This will be kind of the logical reasoning I would like to see how you can express it in the final exam. All right? That's something you want to see, okay? And by the way, I think the exam day will be released very soon. I do know when it is, what department just told me today, but I'm not supposed to tell you. It's kind of informal. But it's going to be around the end of the exam period. Please just wait for the registrar office to post it, and then once it's officially announced, I'll give you some plan. Maybe we can do 1 or 2 review sessions for you guys just to go over different concepts, right? Just get you prepared. I'll also give you some tips, maybe in the last lecture, about how you can get prepared, and also to give you some example questions to see. But it's going to be purely paper and pen. Okay, look at it. Now, this page is very important. Just see how the implication can be understood. All right, and we talk about one of the requirements, right? If you want to compare some objects, presumably it cannot be null. Otherwise, you got null pointer exception. Compare that with null. It should always return false, right? It's basically phase number 2. All right. And then we talk about JUnit assertion. Whenever you talk about assert the same for reference variables, you're just comparing the addresses, right? That's all you got to know about assert the same. Also, if you actually got assert equals, now you have to distinguish between the cases. Case number 1, If these two expressions are primitive type, like integer, Boolean, you're just using equals, just comparing their value. Very simple case. Case number 2. If the two expressions over here are reference type, that means it's going to boil down into expression 1 dot equals expression number 2. All right. Now be careful here, because if you put expression 1 here, or if you put expression 1 as a second argument, it's going to impact about which version it might be called at the runtime for the equals. Because we said that if you got any method called like this for the equals method, which version we're going to call for equals method here depends on the dynamic type for the context object expression 1. If the expression 1 happen to have, let's say, point v1, then we should call the default version, because that one does not override the equals method. If expression number 1 happens to be of dynamic type, point v2, in that case, you will call the overridden version, right? There's all sorts of discussion there we said last Thursday. So please refer to the recording if you need to. And so this will be all sorts of stuff you have to put all together in the ultimate cumulative exam. So why not start going over the materials again, so you don't have to cram all the information maybe the day before. Hopefully not. Right, so we did all sorts. We did examples about assert equals over there, and you may want to also compare again to yourself. If I put P2, P3 versus P3, P2, which version is it going to call? Sometimes, even though you're calling the same version of the equals method, let's say there's an overridden version, but different part of the code in the equals method might be executed. To see exactly what I meant, you can go back to the recording from last Thursday, right? I also explained that in the class last time, all right? And then we did more JUnit test cases for the point class, right? So that's really the only running example we have done so far. So that's pretty straightforward. That's basically what we did last time, right? Just about different JUnit test cases. We didn't really cover the JUnit test methods like assert equals, assert same, in your written test number 1, but they will be covered in written test number 2. So it doesn't hurt to really start going over them, right? Clarify, and then ask TA, ask myself. Good for your learning. And today, I want to do one more example about the equals. That one there is going to involve array, or like a collection. So that's also going to be very relevant to your programming test number 2 next week. Okay. Any questions from last Thursday? All right. Let's now talk about this new example here. So we are basically going to define the equals method in 2 classes. What we learned earlier was something about point and point collector. So now I just changed that a little bit. Let's say person and also person collector. Each class is going to have their own overridden version. So now we got object version, person version, and also person collector version. So now we got 3 versions over here. All right, so that's something you want to really get used to about which version really is being called at the runtime, right? I'll go over some highlights about the example together with you, right? Okay, let's now take a look at the definition right away, right? It's pretty straightforward, okay? And of course, you can also go over the lab number 3 solution with me in the video, and then I also walk you through about how you can define the equals method in the various classes, okay? So let's say we have a person class, right? Person class over here. We got first name, last name, weights, and also heights. And phase number 1, 2, and 3 are just very standard, basically what we did earlier. I kind of combined phase number 2 and 3 by the disjunction operator, right? That's something we kind of discussed, right? So these 2 are straightforward. And then we do the typecast when we know that we are reaching phase number 4. And then we're simply comparing the weights, heights, first name, and last name. So we're just saying that for the purpose of this example, 2 persons will be equal if they have the same first name, last name, weights, and heights, let's say. Okay. So of course, whenever, let's say in the programming test, if you're asked to really implement the equals method, always look for hints, maybe in the comments, about how do we define the equality between these kinds of objects, right? Depending on what attributes are relevant. It should be given to you explicitly as hints in the actual comments, all right? All right, so that's about how we define the person's equals method. Pretty straightforward. We don't need to say too much. So there are 3 possible exercises for you guys to think about. We actually have covered them, all of them in a different example, in the point V1 and point V2. Okay, think about Q1, Q2, and Q3. Especially, you can see for Q2, it's about short circuit evaluation, right? Think about whether or not, for example, null pointer exception might be occurring at the runtime, given this particular order of the arrangement of the operands for the disjunction operator. Right? So these three questions is something that we have already gone over, except for the Q3, which I'm going to go over with you. For Q1 and Q2, exercises for you. All right? Go over, and if you got any questions, you can let me know. Exercises. And let's now do maybe Q3 together. Okay? It's now referring to line number 11 and line number 12. Okay? Let me highlight it, and then we'll talk about it. Line number 11 is over here. And line number 12 is over here, right? It's a simple question. It's asking about which version of the equals method is being called. So right now, we actually got at least two versions. We got this version of the equals method from person. We also got a default version from objects, right? At least two. Is this equals method here calling either one of them or something else? If you look at the code. To determine, you have to think about what's the actual type of objects that's being pointed to by first name and last name, basically. Once you can follow that thoughts, it should be very straightforward. Yes, go ahead, please.
I think it's a string equals method.
Yeah, I agree. Okay. So your fellow student was pretty much right. So the way to see that is like this. So let me write it down here. For example, let's say for this line here. Okay. I'll make it very explicit about the decision making for you. Okay. Let's say in the test. So what you can do is let's write it down first. So we got this dot first name. And then we say dot equals. And something over here. Whatever that's really past this argument doesn't really matter about which version is being called. What really matters is about the context object for equals. So what's the context objects? It's going to be this particular expression, this dot first name, right? Let's be a little bit more precise about, because sometimes you might have a longer dot notation, in which case you got to do the similar reasoning. So first of all, let's start with this. So this over here is really referring to the current class, which is person, right? So this over here is person. And then we say under this, we want to go to first name. The first name is right here. Right? You can see first name was declared to be string. Right? You can see it's a string over here. And of course, you can only assign a string object to string address. So we know that dynamic type must be a string object. Must be. Okay? So here you can see that first name over here, we know that it's a string. So we figure out this particular context object is actually a string. It's not really person. So the version of equals is going to be called will be the string version, which is part of the Java API. But I can think about it just going to compare character by character in the string. Right? That's something also start using maybe since lab 0. So the equals here is going to call the string version. Okay? We're going to see something that's a little bit more sophisticated once we get to the person collector class, which will do the similar exercise once more. All right? But it's a simple one, just to warm up. Okay? Any question about this? Again, the essence about this solution here really is you want to look at the method that you want to analyze about which version is going to be called. And then look at the context object, anything that's before the dot right here, and figure out its type. Once you figure out its type, you can know which version is going to be called. Later on, once we dive very deep into inheritance, we're going to see that sometimes it might be a little more sophisticated. You got to do some tracing, but we'll get there a little bit later. But for now, you're fine. Okay. All right, that's about Q3. And please look at Q1 and Q2 just for exercise, but it's something we have already covered. Okay, so let's look at the slides. So we are now done with slide number 23 and 24 and 25. And let's now talk about collecting persons. So just another class. Basically, it's something called person collector. And that class over there, okay, let's now, so if you look at that, it's a very similar to the pattern we have been talking about. So person collector just have an array of persons. And then we have some integer counter, NOP, number of persons, to keep track. And then you have some method there called add person and also get person, etc. But what we're going to focus on will be how do we define an equals method for a person collector. Okay? Let me sketch something very quickly, right? Here. Okay? What we're doing is, so this will be the full implementation there. Of course, you guys will have to maybe dive deeper into the code yourself. I'm going to highlight to you which part you want to focus more on. Let's say, for example, if I got, without leaving a trace, conceptually it's very simple to think about. Let's say I got persons collector 1 pointing to some person collector objects. I got person collector 2 pointing to another person collector objects, right? The main thing I want to compare for equality would be, let's say here it got array of persons, an array of persons, and this is the array, and also this is the array. So we got a number of persons and also number of persons. In order for these two person collectors to be equal, at least they should have the same number of persons, right? If one has 5 persons, the other one has 6 persons, they are not the same right away, right? Let's say this one here got 1 person, and this one also got 1 person. So that means index 0 over here has 1 person objects. Index 0 here also got 1 person objects. So we should really go deeper into the next level. Not just that we are going to not restrict ourselves only to the person collector, but we have to go over to the person objects as well. How do we compare if 2 persons are equal? Last name, first name, weight, and height. This is something that we already defined in the previous page. So this is something I will highlight to you, but you also got to keep, you got to remember. Whenever you're doing equals method, it's very common the equals method in one class may have to depend on the equals method of another class. It's very common, which you will see today and also in your practice test and for sure in your programming test as well, right? Just keep that in mind, okay? But we're going to look at this all together, okay? Let's now take a look at the person collector class, okay? Let me just do a little bit of annotation, just go over with you about the code, and then we'll trace maybe some test cases all together, and then that'll be it, right? Of course, the detail study will have to be up to you. All the codes is already on the lecture slide. Please go over them. The best way for you to really see which version is going to be called is to put a breakpoint there and then step into to see which equal is being called, which we did in the very beginning of the equals lecture. Okay. So we got person collector here, right? Let's look at the attributes very quickly. So we got persons, which is an array of person. We got NOP, integer, right? These are the only 2 attributes, just to keep it very simple. Of course, in the actual lab or in the test, you might have more than these attributes. It's possible, but the idea will be really similar. And we have the constructor here, which will just initialize these 2 things properly. And also, we got add person, which will go from left to right, right? Adding from left to right. And also, we want to get what's the value for number of persons. And also, we want to get all the persons. The length of the return array should be corresponding to the length, right, of how many persons you have, right? Very straightforward. Let's look at the equals method here, right? This will be phase number 1. This will be phase number 2 and 3 combined using disjunction. Also the same as before, no trick over here, right? So these 2 lines, you can simply just remind yourself they are very standard, okay? One thing you guys may want to be, what you may want to watch out for would be, in the written test or maybe in the exam, I might give you one particular implementation for the equals method. For example, let's say for example, right? I might just change maybe this operator over here from or into and. And then I might just want you to explain to me, is this going to work? If it doesn't work, give me some example, something like that, right? So it will be all sorts of variants of the code you want to really play with, right? To see how things work. All right, the next part, we're gonna cast the OBJ from objects into person collector, right? And then this is the main variable I want to point out to you, okay? Let's now take a little bit closer look. We are basically using this Boolean variable called equal to somehow help us to return the result. Okay, first of all, let me highlight it in different places. So we say equal initialize to be false. And then if we know that the number of persons and the number of persons between the context object and other are the same. For example, let's say one person collector store 5 persons. The other person collector also store 5. In that case, we are going to override this value here to be true before we try to do a person by person comparison, right, over the array. That's something we'll see as well. And then this one here, the loop here is very standard. We just go from I equal to 0, and you can see I less than this.nop. That one is basically what you did since lab number 0. That should be also no surprise to you. And then I++. One thing you gotta watch out for is this part over here, right? We basically have extended the Boolean condition in the middle of this for loop. What does that mean? That means we should be able to go for another iteration if this is true and also this is true. Meaning that as soon as, for example, this equal here becomes false, we should exit from the loop right away. So that means, let's say if you got 100 persons in the array to compare, as soon as we realize there's no way for these 2 person collector to be equal on the 5th person in the array, we can set the equal to be false, and then we don't need to continue anymore. Because we set the equal value here to be false, it's going to cause this Boolean condition here to be false, so we're going to exit without having to go over the entire array. It's just going to provide slightly more efficient code at the runtime. However, it's a little bit look ahead of what you're going to learn in 2101, which is the sequel course to this one here. In 2101, of course, we assume proficiency about your Java knowledge, but at the same time, we also want to somehow make sure the quality or efficiency, time efficiency for your Java code. In that case, we have to think about if I'm able to exit from the loop halfway through the array, is it really going to make it more efficient? Right? That's a question we're going to answer in 2101. I just want to throw that question to you. You can think about it, but it's not required for this course. Okay, we got equal here, and then for each iteration, we're just going to reassign the equal to is the current person we're comparing at index I by this person collector and also other person collector, right? Just position-wise, are they equal to each other? As soon as we find out the very first index where this and also other have different persons, and we're going to set the equal to be false. As soon as we set it to be false, we're actually going to make this conjunction false. So we exit from the loop right away without having to look further, right? And eventually, we just return the equal right here. That's the very quick walkthrough about the rationale about using this Boolean variable. Let me just write down one annotation for you, okay? And then we can move on to actually, I'll say one more thing, and then we can move on to trace some code. Okay. So you want to think about this equal here. Okay. You want to say as soon as the first persons in this and other. So this and other, they're both person collector, right? This will be person collector, other, which is cast into person collector right here, right? As soon as the first persons actually are found to be unequal. Are found not equal. Right? It's a very important insight into understanding this Boolean variable here. Okay? Of course, at the same time, let me give you a little bit of idea about when you study for this code here, also question yourself. Do we really have to set, for example, this value here to be false? Would it work if I set it to be true? One variance. Second variance. Would it really work if I let this one remain to be false? Is it going to work? Right? Think about these two variants, right? That will also help you understand more about this kind of combination about initializing to be false and then later on reassigning to true will be the only combination that's going to work. But what about other combination? Why would it not work? That's something you got to think about. All right? All right, let me do one more line and then we can move on to do some tracing. What I want to do is, let's say this one here, okay, right here. So guys, let's now pause for a moment and look at what I just highlighted in pink, right here. Apparently, we're calling the equals method here. And now we actually got to think about which version of the equals method is going to be called. Before you shoot the answer to me, let's think about what are the equals method that we know about that exist, so we can choose from. Okay, let me write down the option for you. So the equals here. So what are our options? Option number one could be, it could be the one from maybe person. Or it could be the one from person collector. And or it could be the one from objects. Or it could be the one from maybe string. Of course, this list can go on and on and on. Of course, if I assume that the point V1 and point V2 are in the same project, it could be point V2, right? But let's not go too far, okay? So let's say these four are the options here. Before I go over the reasoning together with you, which version is it going to call? Person. Okay, good. Awesome. And your fellow student was right. It's going to call the person version, but let's see exactly how we can figure that out, right? Let's do the similar reasoning as I did earlier, like this, right? We're going to look at the dot expression, dot notation, and see exactly how it can be understood, right? Let me make a separate page for this. Okay. So we are basically doing the following. So we have the class called person collector. Right here. And in the context of the equals method, right? In the context of the equals method, we basically write this line. We say this dot persons I dot equals. And dot 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 doesn't really matter what it is because it's only determined by the context objects. And of course, the persons is a person array, right? That's kind of the relevant part you should really know. Okay, let's now take a look at this line here. Let's start with this. This over here should just correspond to the class you're at, which is person collector, right here, right? So that's the person collector. So we know that this one here of the type person collector. I'll say PC, all right? And we move from left to right. And then we try to say this dot persons, right here. So this dot persons is really referring to the attributes in the person collector, right? And that one there is going to refer to the persons right here. So that one there is going to give you an array of person. Okay with this? Okay. So think about it's really this line here, right? Referring to its attribute. And then we got this array indexing notation here, right? And that one there really just about referring to the member or element type in the array. And that one there, of course, you can think about this. Okay, let me just expand it a little bit further. And now, if we got this whole thing, it's really the left-hand side of the dot. Okay, and that one there, of course, let me just be more complete over here. The I here, right here, is really referring to the person right here. Okay, the person right here. The element type for the array. Okay, so the whole thing, we are really doing something that equals, and then the whole thing on the left-hand side is of type person. All right, so dynamically it's going to be a person objects. So we can draw the conclusion that equals method here is going to be the version of person is invoke. Right? I think this one is definitely a little bit more sophisticated than the previous one, but you can see the idea, right? Whenever you want to analyze about the dot notation, go from left to right. Start from the left-hand side, the leftmost, and then go dot by dot. Okay. Okay. Let's now take a look at some example here. Right? So the one I'm going to go over would be, we're basically done for this lecture here. I just want to go over with you maybe one or two assertions so you get some idea, and the rest will be kind of up to you. But I can maybe post maybe some video there for those of you who may not feel so confident about tracing. You can also look at the video as well. But for the lecture, we don't really have to. But I'll just give you some idea. We'll trace maybe at least one or two together. So slide number 27 is really the pages I really have on my iPad over here. Right? You can see we got one here, we got one here, we got one here, we got one here. I kind of split that entire slide into 4 different pieces, so you can go block by block. Let's only do block number 1 just today, right? You can also do block number 2, 3, and 4 by yourself, which gonna involve adding different persons into different person array, and then you're going to see how you can compare them. I will highly encourage you to do this kind of tracing. It's gonna help you a lot about understanding. But let's get some idea, okay? I'll make sure I also give you some tutorial video. You can go over them as well if you want to go over with me in the video. Okay, let's look at one of them. This one is already interesting enough, okay, even though it's pretty simple. Okay. So let's see this. So we are creating basically P1, P2, P3, and P4. We got 4 variables over here. Just by looking at this, let's say it's a E-class question. After these 4 lines, how many different person addresses are we going to have? 3 or 4? 3? How did you tell? Yes, exactly. Each use of the new keyword is going to give you a new address. As simple as that. All right, good. Okay. Okay, let's now take a look very quickly. So let's trace. So we got, let's say, P1. Okay, it's going to be A180 and 1.8, right? Right here. It's not a very meaningful name, but just for illustration. Okay, you can feel free to modify that as you wish. So we got P2 over here, which is also going to be AA, 180, and 1.8. And we got another P3 over here, which will be B200, 2.1. B200 and 2.1. All right. And P4 is not going to involve the creation of a new object. It's just about creating an alias. Look at this one here. So P4 is going to point to wherever P3 is pointing to. Right here. Okay. And of course, let's just do something very quickly. So assert false, assert true, right? Let's say here, P1 equals P2. We know that P1 and P2 are different objects. So that one there is going to be false. Since we said assert false, false, pass. Right? And P3 equals P4. This one here. And because P3 and P4, they are the same object. So this one here is going to be true. We say assert true, and we got true. Pass. Right? Easy to see. But let's now look at these two. It's going to be interesting. All right? Take a look at these two for now, and at least tell me which version of the equals method that's going to be called. Save your answer. Okay? I'm going to write them down aside, because there will be some interesting tracing we can do quickly. Let's say this one here. I'm going to put star, and this one here, star and star. Okay? So star over here is going to be P1 dot equals P2. And star star is P3 dot equals P4. All right? First of all, why don't we start with what's going to be the return value for this equals and this equals? Oh, sorry, let me start question 1 first. Which version of equals is going to be called here? Which version? Person collector, person string? Person, okay, because you can see dynamic type for P1 is person, right? Okay, you can see that easily. So P1 and P3, you can see dynamic type, P1 and P3, dynamic type is simply person. Well, obviously, it's going to be the person version. Okay. So let's now, first of all, let's annotate about P1 and P3, which are the context objects that happen to have the same dynamic type, just happen to be. Okay. So these two has the dynamic type person. So we know that the equals method is going to come from the person class, right? So equals here and also equals here is going to come from the equals method from the person class. Okay, question 1, pretty straightforward. Question 2, what's going to be return value for each one of them? What about the first one? P1 dot equals P2. Just true or false? I heard false. This one here, if you look at P1 and P2, right? P1 and P2, somehow, even though they are different objects, I agree. But A, B, A, 180, 180, 1.8, 1.8, isn't that corresponding to what we are comparing in the last stage? Right? So it should be true. How about this one here? This one here, P3 and P4. That one's also very interesting. Let me connect to the logical implication I mentioned earlier. We said that if two objects over here are reference equal, they're pointing to the same object, then it doesn't matter how you define the equals method, they're going to be guaranteed to be equal. That's also true. So question number 2, what's going to be the return value for both of them? Just true. All right. Question number 3, which is very important. Okay. So this one is going to be true, and also this one is also going to be true. So we know that both lines are going to call the person version of the equals, and both of them are going to return true. Now here's the one I'm interested. Even though we are returning true, but where exactly did we return true? It could be returning true from here. It could be returning true from here, right? Of course, it cannot be returning true from here because that's returning false. So there are 2 possible places. Now I'm interested in knowing where exactly. Okay? Let's start with, let's say over here. Let's say the very first one. P1 dot equals P2. Where exactly did we return true? Which phase? The last phase, yeah, true, because you can see P1 and P2, they are not equal to each other. And also, their dynamic type is actually the same, though we are okay. So we get to the last stage, right? So this is where, so star, the first version, return true. Okay, that's very important. Okay, what about star star over here? It's also returning true, but is it also returning true from here? Not really, right? Okay, from much earlier, right here. Because this, which is P3, and also OBJ, which is P4, they are just happen to be the same objects. All right? So that one there, I'm just going to say this. So this, okay, I think, how about this one here? This one here is basically corresponding to phase number 1, right away. So this is where the star star returns true. All right. So I think this one gives you some idea about how to keep tracing. But of course, what we haven't done is about the array. Okay. What I really encourage you guys to do as exercise would be, we got number 2 here about person collector. Number 3 and number 4 also about person collector. So you can feel free to print out the starter page over here. I already visualized most of the objects for you. You just got to draw the arrows yourself. And then try to convince yourself why each assertion should really just pass. All right? Try to do this one at least on the paper, I would say at least. And then you can do that on Eclipse as well. And then I'll also post maybe some walkthrough video for you. You can also take a look. Yeah, question? P3 and P4. So P3 and P4, yeah. So P3 and P4, apparently you can see they are the same objects, right? So when you, and we know that equals method from the person is going to be executed. So if you look at that, when you execute this branching condition for phase number 1, this will be the P3. And obj, the argument will be the P4. Because they're equal to each other, so return true right away. You don't even get to the later phase, right? All right. Good. All right, and let's see. Okay, I think you guys definitely deserve a break. Give me one moment. Okay, so we are basically now done with this object equality lecture, right? So I will definitely encourage you to really download the code and do the exercises. It's going to help a lot. Okay. All right, if no further question, why don't we take a short break by taking attendance, and then we'll start a new lecture after the break. Okay. So please get your iClicker ready, and then we'll take attendance. Okay, so before the break, we already finished the lecture about object equality, right? Let me close it. And this will be the very, very big and exciting lecture for all of you, right? So this is going to take us at least, including today, 6.5 lectures basically. But we're going to dive into systematically about all the issues that's involved in the inheritance. Lots of things to really learn. Anything that we learned about static type, dynamic type, typecasting, polymorphism, you may have heard about it. We're going to learn them all deeply. Okay? We're going to use some example as well to actually show to you. All right, so let's see what we're going to learn. And what I want to do is, before we even talk about inheritance, let's look at some given open-ended problem first. In our case, it's going to be a student management system, which is a problem I kind of sent to you guys a little bit earlier today. We can look at that again for a few minutes, just in case you haven't got a chance. But we're going to look at, without the inheritance, how can a design somehow violate certain design principle? Even though this course over here is not really about software design, but I think you guys deserve to learn at least 2 principles. I think that's the most immediate relevant if you want to learn about inheritance. I'll get there, okay? So we're going to see the alternative design without inheritance, how they actually suffer from imperfection by violating some design principle. That's at least what we want to go over a bit today. And then the most superficial understanding about inheritance is you can use the extends or even super keyword, and then you can somehow kind of save some code by calling certain maybe methods from the superclass to maybe eliminate some code duplicates, basically eliminating code duplicates. That's the most superficial way of thinking about inheritance, but there's much more to it. But we still got to cover this first. So maybe today and possibly about the very first half on Tuesday. After these, we're going to spend all the remaining part to talk about much deeper meaning about inheritance that we should learn. Okay, static type, dynamic type, especially the way I would like to think about all these things will be something about expectation. I'll show to you exactly what I mean. But that one there is going to come most likely Tuesday. Okay, and then we're going to talk about polymorphism. Okay, we'll see exactly. By the way, poly I believe is Latin. Poly simply means multiple, and morphism simply means shape. So we got multiple shapes somehow for variable assignments. It's totally different from how you have understood how the variable assignment should be done for reference type. I wouldn't say it's totally different, but just extend through it. Okay? Polymorphism. And then the second thing about dynamic binding. Dynamic binding is basically about, depending on what the dynamic type is for your objects, you're going to call some version of the method in the inheritance hierarchy. That's something we'll see. Right? It's going to be basically based on our understanding about equals method, but generalize it. And typecasting. Right? We didn't even say about why could you actually cast maybe from point V2, from objects into point V2. Can we do it the other way? Well, can we cast maybe from point V2 into string? Can we cast from point V1 into point V2? Things like that. The answer will come a little bit later. So there is some systematic way of doing this, which is implemented by Eclipse. Whenever you want to do any typecasting that's not really legal, it's going to give you a compilation error. Okay, things like that. Well, we'll get them. Right, so that's basically the big topics we're going to go over one by one throughout this lecture here. And after inheritance lecture, we still got about 3 to 4 classes before the end of the semester. And then to really transition smoothly to 2101, the data structure course, we'll talk about recursion. Okay, that'll be the plan. Okay, why do we need inheritance? So let's now take a look at one motivating problem here, which will be the student management system. And for now, I assume you guys don't know about inheritance. Think about without inheritance, how would you design your classes? Okay, at least I want you guys to take 1 minute or 2, go over, let's say 1 minute, okay? Go over this problem description here. It's gonna be the example we're gonna use throughout this lecture. I mean, throughout the entire inheritance lecture. At least you understand about, get yourself familiar with the vocabulary, and then I'll dive into 2 possible designs without the inheritance. And we're gonna learn about why they are not as good, and then we'll get to the inheritance version. Okay, that'll be the plan. Take 1 minute to read through it. Think about what classes you might want to create and also what methods you may want to create. With what we have learned so far, you should be able to implement this student management system without any trouble. Of course, without using inheritance. Okay, just one more moment. And then we'll speak a little bit about the nouns and verbs that will be relevant to our purpose. All right, so everybody got a chance to read it, right? If you haven't really got yourself familiar enough, take over the weekend to really get familiar with this. Okay. What we said earlier when we talk about the OO in general, you can find the potential candidates for classes, attributes, and accessors by identifying the nouns. And also mutators can be from the verbs. It's just a very general principle. Doesn't really mean every noun should be turned into something. Doesn't really mean that. You have to make a judgment. Exactly how the judgment should be made is something you will do in a later course, not in this course. We always tell you what classes you're going to be given, which is okay for the purpose of this course. All right? So if you go back to the slides, I kind of highlights about the stuff that we should be watch out for. Okay? Let's now take a look very quickly. So let's start with student management system. This will be one class we want to define. Apparently, student management system is going to collect collection of students. But student can be either resident or non-resident. So either we have resident students, and also we have non-resident students. All right? Both of them are some kind of students. So which I will also say students. So it seems like we got 3 different concepts. We got like a general concept about what a student is. And also one specialized kind of student called resident students, and another specialized kind called non-resident students, right? So you may have to define, for example, 1, 2, 3 classes, which is completely normal without inheritance. It's okay. But let's move on. So what they share in common, for example, each student should have a name, and also a list of registered courses. Apparently, we made, assuming that we have one class called course, and we might get an array of course, right, in the student class, right? And also, let's say no more than 10 courses. That can be the maximum capacity for the array, right? We can set up. And we can try to calculate the tuition for students, right? Especially with something called base amount. Let's say if I am enrolled into 5 courses, I just add up all the fee together. However, depending on whether you are resident or non-resident, you might be subject to either something called premium rate or discount rate, right? That's what the problem says. But let's now take a look. So we have, you can see here for non-resident students, there is some discount rate, right? I'm just gonna use the same pink, discount rate. So that means discount rate should be only applicable to non-resident students, conceptually. And also we got another one called premium rates. So there's a premium rates over here. And that one they can say premium rates applies to resident students, right? So these are the important attributes and methods that we want to be able to calculate, okay? And also very important for you to note, you have some version about calculating the base amount for the tuition for students in general. However, given the discount rate and given the premium rate, you may actually have to calculate tuition a little bit differently, given the base amount, right? So think about the base amount over here is more like version number 1 for calculating tuition, right? And also you got discount rate, which is going to give you maybe another version over there. And then this one here, premium rate, is going to give you another version, maybe version number 3, etc. Right? That's just our initial sketch about the ideas, right? So, but these are the critical terms. You should really get yourself familiar. We're going to use these terms in all the subsequent lectures to understand different concepts. Okay? Any questions about this? Okay? So I'm going to present to you 2 designs which don't use inheritance. And we're going to criticize about them, about which design principle they're going to violate. Before we do that, let me give you 2 very quick definition of 2 design principles. Let me go over them with you very quickly, conceptually, and then we're going to apply that into these 2 designs without inheritance. Okay, design principles. Right here. Okay. So we talk about design principles. And these are very practical design principles. You don't need to wait until 3311 to learn them. Okay? You can learn them right away. Okay? They are very straightforward, intuitive. The number 1 is something called cohesion. Cohesion simply means all the attributes and methods you define under a common class, they should have some unifying thing. They should be somehow related to each other. You shouldn't really add some method or attribute that simply have nothing to do with what the other methods or attributes are about. Okay? Cohesion simply means the attributes and methods in a single class should either you can say serve the same purpose. Or another way to put it would be they actually they should be under the some unifying thing. Should be under a unifying thing. Okay? Cohesion, for those of you who maybe took 2031, maybe the C and Units course, maybe you will or you have. So cohesion here has some very nice, it's a very nice principle, that Unix system, you know, the system we're using in, or the Linux system that we're using in the lab. Okay? Basically, so the so-called Unix principle. You know, you have used maybe some command like a ls, maybe cd, you know, etc., right? Different commands. The principle about cohesion is for each command, you should only do one thing and do it well. For each class, you should only have one single thing and make sure that one is followed faithfully. Okay, that's about cohesion. Each command should do one thing and do it well. If you haven't really taken 2031, that's okay. You know, once you get there, you will see what I mean. Okay? You shouldn't really have a single command that's actually trying to do 2 different things. Cohesion. And the second one there is something called single choice principle. It's just the name. But single choice principle conceptually simply means whenever you want to somehow make a change to your software, the number of places you want to make the change should be minimum. Hopefully 1, but should not be multiple. Should not be more than necessary. Okay, I'll put it down. A change to be made should be on a minimum number of places. Okay, of course, the principle itself is a little bit vague over here. When we say places, what do we mean? The places over here can maybe, in our context, it could be about the number of classes you have to make the changes, or the number of methods. It depends on which example that we're talking about. We'll see. Okay, could be the number of classes you have to change, or the number of methods you have to change. And the minimum over here, we say minimum doesn't need to be 1, but it should be no more than necessary. Not necessarily 1. It will be ideal if it's just 1. Cannot be 0, right? You cannot really make a change by changing nothing. It's simply contradictory. Not necessarily 1. But no more than necessary. And just to give you a little bit more intuition, the easiest way to violate the single choice principle is by having duplicates in your code. The typical violation about single choice principle is when you have duplicates. And what would be the most common way to really satisfy the single choice principle? Have helper method, right? Which we cover in the OO review. All right, so these are the two design principles. We got cohesion, and also we got single choice principle, right? So these two are very, very fundamental design principles. And it's actually nice to really see how these two principles can be satisfied if we use the keywords in Java related to inheritance. And either or both of them will be violated if we don't use inheritance. We can see that nicely, right? Got about 15 minutes. We'll see, maybe we can do at least one design, and then we can continue on Tuesday. We'll see. Okay, design number 1. Design number 2 is actually on the slides. Let's do design number 1 here. I have it on my iPad, right here. Okay, let's now go over the code structure a little bit together. Okay, just get a feel. So let's say I got a single class called student. Let's not worry about student management system just yet. Let's say only the student. Let's focus on students. How do we really implement the ideas about students, resident students, and non-resident students? Meaning that how do we store premium rate and discount rate, right? Let's think about that too, first. So we have a class called students right here, a single class. And design the temp. I'll give you some quick insight right away. Design attempt number 1 is usually when you are trying to use a non-OO language to simulate OO. How to use a non-OO language, for example, C. Right? C, which you're gonna maybe you have learned already in 2031, it's not OO, right? So is it possible to somehow simulate about what we talk about in OO in C? There's a way, but it's very kind of not nice. We'll see. For example, C to simulate OO. Okay, that's it's a little bit more like a more advanced insight, but I'll just put it here. And let's take a look at the attributes we have. So we have courses, and we have number of courses, very standard, right? Just a pattern. Also, we somehow decide, if you remember, the premium rates belong to resident students, and the discount rate somehow belong to non-resident students. So premium rates and also discount rate. And just for clarity, let me just remind you right here. Somehow we want to have this class over here to really accommodate both students. That's the intention. So this one here is relevant to resident student. So you will see me writing RS very often, just an acronym for resident students. And also for discount rate over here is non-resident students. Okay, we want to accommodate both. And the most important attributes is this one here. Integer kind, all right? Somehow we are explicitly indicating the kinds of student we have. So we are making some assumption. This integer over here, we say that when it is equal to 1, that means we have some resident students. And when it is equal to 2, it could be some non-resident students. So the good thing about having this integer here, rather than Boolean, if you say Boolean, it can be either true or false. You only got 2 possible students you can encode. But if you got integer, you got 2 to the power 32 different students you can encode, right? But that's another concern, okay? Okay, we got integer kind over here, and then you can see that in the constructor for the students, we have to explicitly put kind over here. So let's draw some connection here. Remember when we talked about static variables earlier, we say that without using the static variable, you have to explicitly pass the ID when you first create the objects. And we say that if you have to manually manage the ID, it's not a good design. Similar over here, you're manually managing the kinds of students yourself as well by passing the kind. That's also not good. Let me give you one example here. Given this, how do we create different students objects? Okay, let's say this. So let's say we want to have, let's say, 1 resident students. So what we do is we can say students RS will be new students. And we're assuming that it's going to be 1 for resident students. All right, and let me create another one. Let me also create the one for non-resident student, which I know is going to be 2. So what I will do is I'm going to say students over here, NRS equals new students. At least I'm showing to you how exactly the constructor should be used. You can see we have to explicitly pass 1 and 2. If we got 10 different kinds, you may have to pass all the way up to 10, right? Depending on which kind you want to somehow create. Let's visualize very quickly. RS is basically pointing to some student objects where the kind is simply just 1. And you got NRS is just another student object over here where the kind is actually 2, right? Let's see the difference here. You got 1 versus 2. That means at the runtime, if I want to calculate the tuition, for example, at the runtime, let me write 2 more lines here. So we got RS, we got NRS. If I say RS dot get tuition versus if I say NRS dot get tuition. So now if you compare these 2 lines right away, right? You can see that the context objects is RS versus NRS, but they are both students, right? That's how we created them. So how can we be sure when you calculate the get tuition for resident students, it's actually going to calculate based on the premium rates? So I can do one more thing here. You can think about you also got premium rates, and also you got discount rate. And also here, you may have premium rates, you also got discount rates. When we actually try to calculate the tuition for resident students, we should only use the premium rates. When we want to calculate the NRS, non-resident student, we should only use the discount rate, right? That's kind of the applicable attributes we should really use. All right, conceptually, that's how we go. Let's now dive a little bit deeper. How exactly should we really define the get tuition? Apparently, the get tuition should really say, I look at the student object over here. I want to first of all look at the kind over here. If the kind happen to be 1, I know that I should look at premium rate. If the kind happen to be 2, I should really look at the discount rate right here. So what this tells you is, in this design here, for every method you want to implement, to really see what will be the corresponding action for that particular kind of students, you will need a very long if-else-if statement to check what the kind is, right? Let's now take a look to see what I really mean, and then we'll criticize this design. So get tuition over here, right? First of all, we try to calculate the base amount, okay? So this is what we call the base amount. And the base amount should not be very surprising, okay? I'll just write it down first, base amount. We simply go over all the courses for this particular students and just add out the fee, right? Add it up, just the base amount. And then if the students happen to be resident students, in which case the kind is equal to 1, right here. In that case, tuition, the base amount should be compounded by premium rates. On the other hand, if we are making this particular call NRS, which is this object here, the kind will be equal to 2. In that case, we should really give them some discounted rate, right? So what you want to think about is at the runtime, you can either execute this branch over here, or you can execute this branch over here, either this or that. And then you will do something specific to this kind inside the branch. Are we okay with this? Okay, good. That's one thing here. And then, of course, if you look at the register, right, we can also say things like if it's a premium, it's resident students, we just give them like a maximum 6, and non-resident student maximum 4, let's say, right? So you still have this kind of a discrimination here. You say if kind is equal to 1, and also else if kind is equal to 2, right? Basically, for every method, you would need this kind of a if then else structure over here, okay? Now, what we really want to criticize is, based on the 2 design principles we had right here, cohesion and single choice principle, which one does this design attempt violates? You can put some thoughts into this, and then I'm going to discuss each one of them one by one. I think that'll be it for today, okay? Let's start with cohesion. Remember what cohesion is. A single class, all the attributes and methods inside should really serve the same purpose. They should be related to each other. If you got anything there that's unrelated to each other, then that means you got violation of cohesion. Based on that, do you think this design here will satisfy cohesion? Anybody?
Maybe not, because for the non-residents, there's a discount, and for the residents, there's a premium, right? And if one of them is not used for the other, so it's those.
Absolutely. Thank you so much. I think your fellow students are exactly right. Before I put any annotation here, think about what somehow when I visualize the object, I somehow gave you a little bit of visual hints. Let me do it again. When you call rs.getTuition, kind is equal to 1. You only have to look at premium rates. For kind equals 1, you never have to look at discount rates, right? So dr over here is never there. Is not applicable. On the other hand, when I try to say maybe NRS.getTuition is a non-resident students, when kind is equal to 2, I will only look at discount rates, meaning that premium rate is never applicable. So this premium rate over here is not applicable. Let's now go to the cleaner page over here. So what we can do, what we can say is these two attributes violate the cohesion. Violation. Simply because premium rates is only applicable to resident students, whereas discount rate is only applicable to non-resident students. Right? So that's how we justify about why this will violate the cohesion. Right? What about single choice principle? Basically, single choice principle here, you just want to ask yourself, do we have duplicates in this code here? Do we? What exactly are the duplicates?
Yeah, like if and else for the common student.
Yeah, exactly. So you can see that this will be one duplicate here. For every method, you have to duplicate this kind of if structure. This will be duplicate number one. And also, you got else if, and also else if. This will be another duplicate you have to write for every method where you want to distinguish between what kind of student I'm talking about, right? This will be duplicates number two, okay? I'm gonna just leave one question here for you guys to think about, and we can continue from this on Tuesday. Give me 30 seconds, please, okay? You want to think about, I just illustrated to you, we got repeated if condition, one here and also one here. But now think to yourself, given this, if I want to introduce a new kind of students, what exactly am I going to change in this code over here? And also, if I'm going to remove one kind of student, let's say the resident student is no longer possible for the university. In that case, how can I modify the code? And for this change over here and for this change over here, do I have to modify multiple places? If I have to, then I'm violating single choice principle. So single choice principle over here is slightly more kind of abstract principle that we really had to see some code. That's something I'll pick up maybe from Tuesday. All right, take a look at this example here, and then we'll start from something that's deeper into inheritance on Tuesday. Okay, see you.